Hi there, welcome to the RPS project. I'm Richard and today it's transistors again. Well, I mean it seems like a very small thing. A BJT NPN transistor, you just plug it in, turn it on, shove some resistors in there, not a problem. Actually, it's turned out to be a lot more than that. These are fiddly little things that look like they should be really simple to set up, but can give you a damn big headache when they just don't do what you expect them to. A couple of videos I've been doing on biasing these transistors, just a basic biasing of an NPN in like a class A amplifier type circuit. Very simple. We've just got my biasing resistors here. I fixed this resistor up here, the collector resistor, to a 1K resistor, and then I've been changing the resistors on the emitter so I can influence the current through the transistor and how much current I'm going to get on the base to emitter junction. And also, so from what I can make out, this also influences the voltage here at this point and how well this turns on. I know that the turn on voltage is set. The transistor will always want to turn on at a particular voltage, but how does that influence the voltage on the collector as well? Is there going to be any movement in that? Really want this to be as stable as I can possibly get it, but with really good gain. So I put a very small current in here on the base and get a good current, much higher current out here on the collector, and I'll take that to my output. So I've been doing lots of messing around. Now previously I put, get that off, what I'd done is I put my ammeter up there, if you can see that's a bit washed out in it, and I'd put another ammeter up there, so both my ammeters were reading the current through this path and the current through the resistor divider. It seemed to work, give me some information about what was going in there, but I suppose what I really need is those ammeters to be in someplace else. So what I really used the black markers just a bit better. What I'm going to do is I'm going to put one ammeter in there actually onto the base, so I see exactly what's going into the base, and then I'm going to put another ammeter. I have to redraw this. Like that, so it's going to come through that 1K resistor at the top there and then through my ammeter. So I'm going to see what the current is on the actual collector and what the current is on the base. Now before I'd been using 6 resistors along here and I've been going all the way up to 1 meg, but I'm not going to do that this time. I just wouldn't see anything, and my meters, my multimeters just aren't sensitive enough to be picking up that. And besides, if you're only getting nano amps through this circuit, it's not really going to do anything. So I'm going to stick with the I think it's 1K 430 ohm and 260 ohm, and that's what I'm going to have there. And here I'd had a 4K7 and a 2K2 with a 1K up there, and that's what I'm going to work with this time. And I'll have a look at maybe changing these resistors here to 1K and 1K, just because it then gives me a supposed in the middle voltage on this resistor divider. And I'll have a look and see what this thing's doing, see if I can start to make a bit more headway with regards to things like gain, and whether this will move this voltage point here to a point where it's no longer usable. It's either too near the voltage rail or it gets dropped down too far, so it's too near this the ground or the negative rail, minus voltage rail, whatever you want to call it, whatever it is. In this case, I suppose I'd say that's the minus, or the not ground rail, it's the 0 volt rail, really, because it's not ground earth and it's not negative. I'm not going into a minus voltage, so it's 0 volts, 5 volts. Let's have a look at it and see what I'm going to be getting out of this. Okay, so here we've got some, I need a pointy stick, there we go, 2 voltmeters, and with this one it's going to be looking at the base current, and on this one's going to be looking at the current on the collector. Now I've got this little multimeter, this analog one, because that's the only multimeter I've got left, and I'm going to have a look at the voltages that are on the base, the collector and emitter, and across the collector emitter. Now this is a really cheap sort of analog thing, and every time I put it on a circuit it will influence these two. So when I turn on the circuit, I'll have a look at these two multimeters, see what the current is, and then I'll look at this and I'll ignore the changes that are going to happen here, because it is just a cheap multimeter and it will have an effect on the circuit. But I just want to see generally what the voltages are without having to mess around too much. So that to give me an idea that everything is doing what I expect it to be doing. So anyway, let's stop talking about it and let's get on with it. So first and foremost, let's turn it on, and the first circuit I've got is 2K2 and a 4K7 on the voltage divider, with a 1K on the collector, and I'm going to have a 1K for the on the emitter. The emitter resistor is going to be 1K, and that is giving me 3 microamps. That's right, 3 microamps on the base, and 1 milliamp on the collector. Now I previously done some testing and actually wrote some notes, take some notes on this already, so I've already got some figures, but I'm just going to go through this so you can see what I was doing and how I did it. So now I want to have a look at the voltages. I want to have a look at the voltage on the base, and don't forget it will influence the current because of the way this particular meter works. And on there it is 2 volts. On the collector it is 4 volts. On the emitter, let's see it at that point, is just over a volt. What? 1.2 volts. And across the collector to emitter I have 3.4 volts. So seems okay, but the collector voltage is a bit high, so I'm going to come down now to the 430 ohm resistor on the emitter, turn it on, upper range, and I've got 7 microamps on the base, 227 it says here. I've wrote 222 before, but I mean that was slight variance from what I did last time when I was looking at it previously to get an idea. But anyway, 227 is about what I was expecting. So let's have a quick look at the voltages. Voltage on the base, 2 volts. Voltage on the collector, 3 volts, maybe just over. And the voltage on the emitter, 1.2, 1.3, 1.2 volts, something like that, and the voltage across the transistor collector to emitter is 2.2, something like that, 2.3 maybe, which is actually quite good. It's biased up quite well. 7 microamps in and getting 2.27 millivolts out. That sounds like quite a good gain. Anyway, let's go up another level to the 260 ohm on the emitter, and now I've got 12 microamps on the base and 3.57 milliamps on the get these all mixed on the collector. Base voltage 2 volts, collector voltage 1.8, something like that. Emitter voltage 1.2, and across the transistor, collector to emitter, 0.6. So the lowest reading there for 260 ohm resistor on the emitter is actually giving me, it's basically turned the transistor on, but the collector voltage is now down to 1.9 volts, which isn't leaving me with much room, whereas the 430 ohm resistor is giving me 3.1 volts on the collector, which is great because that means it's got some room for the wiggle when we put a signal in there. Anyway, one of the other things I was going to do is change the resistor bridge, the resistor divider, sorry, to 1K resistors. Make it nice and sort of even, so it's just direct resistor divider. But of course, if I'm doing 1K, the current through that resistor divider will be 5 volts divided by 2000. It's 2.5 milliamps, which is massively more than we need. So I'm burning quite a bit of power there, I suppose, in comparison to what I actually need. Anyway, let's turn it on. Go back to 1K on the emitter resistor. We've got 2 microamps and 765 on the collector. So again, let's have a look at the voltages and see what the effect there is. On the base I have, it looks like 1.8, something like that. On the collector we've got, oh look at that, that is, that's like 4.4 volts. So that's not very good because the collector's way high compared to what I really want it to be. And the emitter voltage is about 1 volt. And the voltage across the transistor, collector to emitter, 3.8, 3.9 volts. That's quite high really. I mean, don't really want anything like that. So let's move on to the next one, which is the 430 ohm, 5 microamps on the base and 1.73 milliamps. So I'm really getting a lot of current gain on this. And what's the biasing looking like now? On the base we've got 1.8, 1.7. On the collector we've got 3.57 3.5, 3.5, something like that. Anyway, on the emitter we have about a volt. Is that right? Looks to be saying just on the emitter it's about a volt, yeah. And across the transistor, mm, 3 volts. Looks like it, just under maybe. That seems quite good actually. It's a nicely biased point. The collector voltage is 3.4 volts or something like that. And the emitter is at 1 volt. So I'm sitting in a nice sort of mid-range point. And I've got quite a bit of gain because I've got 5 microamps compared to 1.7 milliamps. So that seems to work. And if I take this emitter resistor down to the 260 ohm and turn that on, upper range, we've got 9 microamps on the base and 2.73 milliamps on the collector, which sounds like a great amount of gain. The base voltage 1.8 volts, 1.7, something like that. Collector is 2.8, 2.7, something like that. Emitter voltage 1 volt, and the voltage across the transistor, well, that's coming in about 2 volts. So that's not too bad neither. That's quite good. A little bit lower on the collector voltage, but still got great gain in there. So that does seem to work fine on that basis. Now I wonder if, because on this circuit what I've got is a resistor divider that's using, well, I say 2.5 milliamps of current through it. Yeah, I'm only using 9 microamps on the base, so I could get away with much higher value resistors in the resistor divider to give me enough current so that the base has got what it needs to make this work, to amplify. So I don't really need these 1K. I can actually go much bigger, so I'm going to go up to 10K. I'll put 10K resistor in the resistor divider. There we go. And there'll still be enough current in there for the base. I'm sure there will. Anyway, let's go back and restart this whole test again with the 1K on the emitter. 1K resistor on the emitter. And that 6 microamps, 1.86 on the collector. Let's just have a look at the voltage. On the base we have about 2.5, yeah, pretty much 2.5. Of course, seem to be having funny with the current. Oh, leads come off. Getting too rough with it. Let's get that back on. There we go, that's a bit better. 2.5 volts, so the base is nice and stable. The collector is that's about 3.5 volts, something like that. The emitter voltage 2.2, 2.4 volts, and the voltage across the transistor, I have 1.7, 1.6, something like that, across the transistor, so that seems alright. Quite happy with that. Anyway, let's take this down a resistor to 430 ohm on the emitter, and see what that does to it. Now that's quite a big jump up on the base, and the collector is 3.44 milliamps, but that's a huge jump there from the sort of 6 microamps to 72 microamps. That's a much bigger jump. So let's have a look and see what the voltages are like. The base voltage 2.5, looking good. The collector voltage that's 2 volts, and the emitter voltage that's 2 volts as well. So if I measure the voltage across the transistor, I'm not going to get anything, because effectively, yeah, nothing to write home about. Basically, I've got this transistor turned on fully. It's in saturation. There's no voltage difference, no potential difference between the collector and emitter anymore. So this thing is turned on hard, which looks great, but how is that going to affect anything or any signal coming through this circuit? Let's take this down. I don't really need to take this down with the emitter resistor down to 260, because if it's already saturated with the 430 resistor on the emitter, then it's still going to be in saturation. Well, even more, it's going to be driven really hard. Yeah, come out, the base current is now jumped up to 155, but the collector current hasn't really gone up very much at all. So we're turning on other junctions, like the collector base junction on this transistor is getting turned on. This is now running in saturation. It's nice to see that. I nice to see it actually in effect. A lot of time don't see it in saturation when I'm trying to find a nice bias point for an audio circuit. The base voltage has now come down to about 2.2 volts. The collector is at 1.5, something like that, 1.4 maybe. The emitter voltage is at about 1.4, so they're at about basically the same. So across the transistor I should be getting no voltage at all, nothing at all. Means this thing is turned on hard, which isn't really helpful. I don't want it to be turned on hard. If anything, the one case works quite well because it gives me 3.5 volts on the collector, but I want a little bit less than that. So what I'm going to do is I'm going to take this 260 ohm and the 430 ohm and put them in series, giving me 690 ohm, which is less than the 1K, but more than the 430, obviously. But hopefully that'll drop my collector voltage down a little bit more to something that I like, but still with plenty of gain. And there we go, 9 milliamps on the base and 2.6564 on the collector. So let's have a quick look at the voltages. Voltage on the base is pretty much 2.5. That's brilliant, exactly in the middle. I've got even resistor on the resistor divider. The collector voltage is 2.9, 2.8, which is brilliant. It's exactly where I want it to be. The emitter voltage is 2.2, 2.3, maybe something like that, which means the transistor's almost fully turned on, but not quite. What am I getting off this? I'm getting about 0.6 of a volt. So the transistor is on. So I wonder what that'd be between the base and the emitter. If I can get my probe in there. It's about 0.8. So yeah, so the transistor's on. It's almost in saturation, but actually it's given me some nice values, because now I've got 9 microamps on the base, 2.65 milliamps on the collector, my collector voltage is at 2.8, so any signal I put in there should really have a lot of headroom to work with, and should work really well. But will it? Obviously, I think that's a story for another day. For now, the DC biasing point on this transistor, I've got plenty of data. I just need to go through it, have a look at it all and see what it's telling me. See if I get any sort of sense out of it. I'm certainly getting a decent amount of gain. I wonder if I work that out. Now, without going through this beta, or whatever, or current gain of a transistor, effectively, if I just take the output, 0.00, is it 265, because it's 2.65 milliamps, divided by the current input on the base, which is 9 microamps, it's telling me I've got a gain of 294, which is a lot of gain. How useful that it will be when it comes to actually putting a signal in, I don't know, but well, I think what I need to do is take all this data and do a bit of maths calculations. So I suppose I ought to get on and do that. So there we go, some more transistor biasing, looking at the current that's going through the transistors. And again, I don't suppose I've really learned a great deal from this, except that certain things don't seem to work. I've got to see that transistor actually in saturation just by changing some of the resistor values. So what I've really got from that is a load of data. This is the data taken from me doing testing. I've got more than just this one page. Of course, I've got from all the other data from when I've been testing and taking down the values of other scenarios with different resistors, even putting a little signal in there, and I've collected effectively a load of data. So I suppose what I've got to do now is take all this data, put this lot into like a spreadsheet or some format so I can look at this data and try to understand it, so I can understand that transistor, the BJT NPN transistor, just to really get an understanding, get under the skin of it well and truly, so I know exactly how it's operating and why it's doing some of the things it does, and be confident that when I use it in the future I know what I'm going to get. I mean, I could sit here all day and do all this stuff just by doing the calculations, just do the maths, work it all out and go, yeah, brilliant, I understand that. But sometimes you don't always get what you calculate, and you put it on a breadboard or something and you wire it all up and you get something different, or the circuit doesn't work and you're like, I haven't got a clue what's going on. But by doing this experiment, this testing, hopefully when I apply the maths and have a look at the results I got from my actual testing, I'll actually have an understanding of what I'm doing. Hopefully, maybe, well, I'll find out. But I'll keep that for another video. Anyway, if you liked the video, give me a thumbs up, subscribe. All comments are welcome. Do some testing yourself as well and see what you get. See you next time.